So, good morning.
सर केंद्र
Today's
सर
lecture
केंद्र
is
लाल
about
डिपार्टमेंट
the
लग
fluid
गया
mechanics lab, and I will give you introduction about fluid mechanics lab. The code for fluid mechanics lab is ACME 616508. The list of experiment that we are going to cover. List of experiment that we are going to cover in this fluid mechanics lab is to determine the metacentric height of floating vessels under loaded and unloaded conditions. Now, in this experiment, you may understand that a ship that is floating on some ocean, it keeps on vibrating to and fro like this, right? So, at what point it starts vibrating once it is given some fluctuation or given some deflection? So, we have to calculate that metacentric height. So the second experiment is to study the flow through a variable area duct and verify Bernoulli's energy equation. When you keep on studying this fluid mechanics, there is a Bernoulli's equation at after second or third chapter. You will get an Bernoulli's energy equation. To verify that, we have a setup for that, which is called Bernoulli's energy equation apparatus, and then we will do some experimentation to verify what Bernoulli's have equation has given us and what is the actual results, right? Then third experiment will be to determine the coefficient of discharge of obstruction of flow meter, venturimeter, or orifice meter. Again, some equipments are there. As we have a ship, we are having some measuring instruments like venturimeter and orifice meter. When you pass water from venturimeter and orifice meter, you will calculate coefficient of discharge through that while calculating flow, while calculating velocity of flow, discharge, pressure, and so on. Then fourth experiment will be to determine the discharge coefficient for a V notch and rectangular notch. Sometimes we pass water from V-shaped body like this, V-shaped body, right? And sometimes rectangular shaped body. If you pass water from V-shaped channel and if you pass water from rectangular uh, shaped channel, what will be the coefficient of discharge? Coefficient of discharge basically is how much water it is giving. Then fifth experiment that we are going to do is to study the transition from laminar to turbulent flow and to ascertain the lower critical Reynolds number. As we have discussed about laminar flow and turbulent flow in last lecture, yesterday's lecture, that flow which is very smooth without any up and down or to and fro motion of water is called a laminar flow, and slowly it moves to transition when the velocity increases, and then it is very turbulent when it moves to it when its velocity increases to very high value. So particularly there is a number, that Reynolds number. Reynolds number give you a value, whether that value, if the value of Reynolds number is less than 2000, then it is called as laminar flow. And the value of Reynolds number, if it comes out more than 2000, then it will be a turbulent flow. So a Reynolds number is an equation. If you put some values in that, and if the value comes out less than 2000, the flow will be laminar, and if the value increases from 2000, then it will be a turbulent flow. So this experiment is to detect whether the flow is laminar or turbulent using Reynolds number. And sixth experiment to determine the hydraulic coefficient for flow through an orifice. So again, instrument, a device to calculate flow and hydraulic coefficient like discharge coefficient and coefficient of velocity, etc. Then seventh experiment that we are going to do is to determine the frictional coefficient for pipe of different diameter. At our homes or in domestic uses, we have a pipe of half inch diameter, an inch diameter, and 1.5 inch diameter, 2 inches, 4 inches, and 6 inches. In this particular experiment, when the water is flowing from some pipes of different diameter, what is the coefficient of friction related to that? We will study that in this experiment. Then eighth experiment, to determine the head loss in a pipeline due to sudden expansion and sudden contraction. In eighth experiment, when there is a sudden expansion of fluid, this fluid, and sudden contraction, when there is a sudden drop in the diameter of the pipe. Suppose it is the diameter and its diameter decreases to this. This is called sudden contraction of water. So initially the water is passing from this much pipe, 4 centimeter diameter, 4 inches diameter, and then it is slowly passed to 3 inches diameter. There is a sudden contraction of that fluid. So determine the head loss. We have to study the head loss due to this. And similarly, there is a pipe of say 3 inches diameter, and suddenly the diameter increased to 4 inches. Then there will be sudden increase or sudden change in the pressure. Head loss is basically a pressure loss. Pressure loss. Head loss. The head term is used up to which we have stored the water. At our domestic uses, what we do is we have a water tank at our roof of terrace of our houses, and we use centrifugal pumps to increase the pressure of the water and to store it water in the tank. And so we store that water at some height in our water tanks, and then we use that water with a high pressure at our different locations, like in kitchen and bathrooms and all that. Why that high pressure water is available at our tap? Because of that we have stored it at some height. Because of height, its pressure increases. The head is basically height up to which we have stored that water, right? So head loss, so the loss of pressure due to sudden expansion and sudden contraction or some bends. When a pipe encounters and water encounters number of bends, there is a loss of pressure of water. So if you want to keep the pressure high, you should decrease the number of bends in that particular pipe. Number 9, to determine the velocity distribution for pipeline flow with Pettit static probe. Again, there is a that measuring device, that is Pettit static tube. We study the effect of this with the help of Pettit static tube, with the help of some measuring instruments like pressure measuring device, then a container for measuring the water that is discharged from that Pettit static tube, and so on. And last experiment is 10th experiment, to experimentally evaluate free and forced vortex flow. What vortex flow is? When a flow rotates circularly in round shape, you may have seen that if there is a hole at the center of a container, at the middle of center of the container, the water starts rotating. Instead of falling straight away downwards, the water starts rotating. That particular rotation of water is called vortex flow. If you generate that if this rotation is generated automatically, just by giving a hole, the water rushes out from the hole, from the center of that pipe or some container, and the water starts spreading automatically. Then that particular flow is called free vortex flow. And similarly, if you take a spoon and start rotating that spoon in the container, and that particular fluid starts rotating along with that spoon, then that particular rotation of fluid is called forced vortex. So these are the 10 experiments that I have that you have to do in this fluid mechanics lab. And this is the introduction of our fluid mechanics lab. Now I will show you the lab